Okay, so we can start it. Okay, you see here that okay, so good morning, welcome to the course of static on the part of the engineering mechanics. I see that we have more than 13 students. Normally we have 50 students. So once again, welcome to the course. You see here on the screen my name, sorry, telephone number, and also the email. Because the course is taught in English, so maybe should be there can be some problem. So you can again, if you have some problem, please you can send me the sorry, you can send me the message via the chat room or you can use sorry telephone. You can send me the telephone by telephone or by email also. Okay, everything should be because a lot of problem can occur during the course. So you see me again, I check it. Okay, well, this is good. Okay, again, everything should be okay. We are waiting a bit for the other student, but however, I can start it. You see again, here's my name, telephone number, here email, and also during the course you can send me some message through the chat room. Okay, today maybe there's some problem with the keyboard. So here you see that we have two textbooks. The textbook, the first one is a lecture note and problem. Many years ago, when this course, static course, occurred some years ago, I already wrote this lecture note and problem. They are I don't know if you can see it because this one, and also the small one with the problem. So you see here, I have the lecturer note and problem. Some years later, the Bách Publishing House have already published it in the form of textbook. Both are available in the library, so you can go to the library and ask for these texts. However, if you cannot go to the library, just know this week I will post this note and also this slide from this course this morning to the team, so you can join it. However, if you have the form book of these texts, it is better for you. You can go to the library and ask for these two things. Okay, static, and the second, they are the same. However, this one has the nice thing that at the end, or you can ask the people from the library both lecture note and also the problem, because during the course you have a lot of problem. I don't say to you that which problem you should solve it. You can solve anything, but during the course, okay, and send me the solve the problem. At the end of this course, I will repeat it again. So this this lecture note and problem, they are in, okay. Switch off the microphone, okay? If only switch on the microphone only if you need, or send me the problem through the chat room, okay? So I repeat again, you can go to the library and ask for the lecture no problem of static. And what I say, in the book form, this one is in big form, but in the book form you don't have the problem. So all the time you can go to the library and ask for these two things. However, I repeat again that this week, maybe tomorrow, after finishing today's course, I will post step by step these note and problem for this week to the on the team, so you can download it and and enjoy the mechanics. Okay, enjoy really. And for somebody, you see that they are during the over the word, there are a lot of English textbook. So here are very famous textbook from Ibler, from Miriam and Christ, and also from Beer and Johnston. Okay, all you can read it and read like a reference. But it is a very big textbook. If you cannot, cannot read it many times, so you read it is sufficient if you read my textbook. And beside of this, you see that you are at our university, Hanoi. University of Science Technology. They are course in Vietnamese. So sometimes some students like the Vietnamese textbook so much. Okay, so you can read it and make it a reference. However, because we are working in English, so it is better if you can. It is better for you to make the program and discuss and do anything in English. Okay, so. uh, Before going directly to the course, I show you this picture. You see again, because in the title, you see I wrote engineering mechanics. Engineering mechanics have some part. Normally, in the over the word, you split it in two parts: static and dynamics. I will explain it later, but there for your information, in this slide I show you that in mechanics we have two courses, two parts: static and dynamics. So this first course, in this first semester, you are dealing with static. In the second semester, you are dealing with the dynamic. Okay, and dynamic are split in two parts: kinematic and kinetic. Kinematic, it means that you are dealing only with the motion, and the kinetic, we are dealing with the force and motion also. So over the word, the mechanic is split into two parts: static and dynamics. First semester, second semester. However, for Vietnamese course, because I emphasize that you discuss so much with Vietnamese student in the normal course. For Vietnamese course, we combine the first one, static and kinematics, in one course. So in the first semester, they have static and kinematics. Okay, and only in the second semester they have kinematic. Okay, and for other students not from the mechanical engineering, so they have only one course of mechanics. Okay, so it is the first time. Once again, for our course in advanced course, we split mechanic in two parts: static and dynamic. Okay, second semester you will deal with the dynamic. In the first semester you have only static. And what is a static? You see the static deal with the equilibrium of the body, because mechanic deal with the motion under the acting of the forces. But in static, we are dealing only the equilibrium. It means that no motion occur here. It is equilibrium. So in static, we are dealing with the force. I will repeat it again in some slide later. But in this first slide, I would like to emphasize or to see that you have two parts. So first course in static, second course in dynamic. Okay. So you see again that dynamic in the second semester, we have two parts, kinematic and kinetic. In kinematic, we are dealing only with the motion, no force. And because in static, we are dealing with the equilibrium of the force system. So in the second part, you study the motion without the force. And in the most general part of engineering mechanics, we take the relationship between force and the motion. Okay, so you see in static, you study only what happened with the forces, and all body are in the equilibrium without the motion. And the kinematic, you will study only the motion without the explaining why it has emotion, without the interesting about the forces. And only in the kinetic I have motion and force relationship. Okay, for your information first. And now we go to the first part, to the static one. In this first, and the first time, in the first in the first chapter, you will explain the most important thing in the static and as well as for the mechanics. Okay, again, for somebody, for the people who come later, here is the name, telephone number, where are, sorry, if or somebody sometimes want to come to see me and ask for some problem. Normally here it is what C3, it is the office of the department, but normally I am sitting on the C1. Okay, so you see again, here it is my office, C1 224. Okay, and here's the telephone number and email and so on. Later you can see. Okay, so what is static? Is in this first introduction, in the introduction, you see, we will again explain what is static and dynamic. We will explain the most important quantity in the mechanic, and very important for us is the so-called axiom. It means the basic law in static. Each scientific field is based on some law, so-called axiom. Axiom, it means that it is a basic law and nobody can prove it, but we feel it and we assume that it is correct. And other law will be derived from this basic law. So we'll explain here also. So some other important motion is a unit of measurement and numerical calculation. Okay, how we can keep the significant digit, and also at the lead of this chapter, okay, we give some information about the problem, what is the question in the examination for for studying in the study. Okay. So again, and just now you have more time to explain it, to explain what is a mechanic, step by step. What is a mechanic? The mechanic is a study of the field of science which study the uh, relationship between body or forces. The reason of any motion of the body is forces. So it means that I try to find the relationship between the motion and and forces. The body, or I type in normal language, you call it things, the things, okay? Anything or some things are under action of the forces. And under the acting of the forces, the thing or the body start to move. So it means we study the relationship between motion and forces. Here you see, for example, here I said one rigid body, oh, big one, big one. This one, it is the wheel, okay, of the train. And here, this rail also under the action of these forces. What's this one? The second one, under the gravitation force. It normally it fall down. However, I have some line here, and it will keep this rigid body in the equilibrium. Okay, so you see again that the body can move or in equilibrium under the action of the of forces. So, as a definition, we can say that mechanics is a branch of physical science concerned with the state of the motion or of the rest. The rest or equilibrium is only one state of the motion, okay, of the body, or we say of the thing, under the action or that are subject to the action of the force. So you see again, I have the physical science which study the state of the body, and this body can be in the motion or in the rest, in the equilibrium, under the action of forces. Okay, so you see again, I show it this picture again, or some slide, some minutes before. You see that mechanic again here is the branch of the field of the science which study the relationship between action of the motion. And because I say that the state of the body can be in the motion or in the rest. So the first part, we are dealing with the static. It means that the state of the body which are in the equilibrium under the action of the forces. And the second part, surely the dynamic, we will study the motion under the action of the forces. You see here again, static deal with the equilibrium, no motion. Okay, or you see again, I say that no motion, but in some textbook, or we can see that, or move with the constant velocity. It is a bit further or extension of this. With the, we can say the inertial system. With the inertial system, move with the constant velocity, so we can say that it in the inertial system. But for easy understanding, so we can say that the body is in equilibrium. Okay, or no most. The dynamic concept is the body with the motion. In this case, I say the motion with the acceleration, accelerated motion. So you see that if I have a no acceleration, it means that the body will move with a constant velocity. Okay, so for better for us understand well, static deal with the equilibrium, no motion, and dynamic with the motion. Surely with it, I say the motion, I understand well the motion with the acceleration. Okay, and the dynamic again will be split it into part. the kinematic, which did only the motion, but I don't try to explain it why this motion occur. It means that without the consideration of the force, only in the kinetic portion, the very general case. So I have the relationship between force and the motion. So again, this picture, I hope that it is more clear for you and which topic of the first course, first semester static, and is the second semester the dynamic. And really the mechanic is the very basic physical science for other science. For example, for design of machining, for robots, for robotics, for anything. Really, it is a very physical science, basic physical science. Okay, and now we go to the second portion, because for each scientific field, you should specify some quantity for defining. You see here again, you can define the space, length, time, mass, and force. Uh, you speak so much, or we have already spoke so much, or we are speaking so much about the relationship between the motion and the forces. So we are speaking about the motion. Motion of what? Motion of one rigid body. A rigid body should have some mass. Okay? And how we can define the motion? The motion should have, we can measure the velocity or acceleration. For defining the velocity and acceleration, you should have, I can measure it. I can measure the distance, so I should have the length. This length is in some space, okay, and in time also. So okay, with the defining the distance, the length, and time, so I can define a velocity and so on for acceleration. So you see again these quantities: space, length, time, and mass, and the forces. What is space? Oh, space. Anybody can understand well what is space. The geometrical region occupied by body. So you see that if I want to study the motion of the body, I should specify space. Okay, so you see that the region occupied by body, and this body, we can specify this body by the position. Position can be defined by, for example, linear measurement. It means the distance, or angular measurement. It means that I can measure it to the coordinate system. With the space, I define coordinate system. Also, for example, width, I, and Z. It's so-called Cartesian coordinate system. In Vietnamese, we call coordinate system Descartes. Okay, Descartes. So I can measure it by distance, by linear and or linear or angular measurement. So in this space, I can measure the position of a point in space, and the size also of this H rigid body. So it's so-called length. And for example, meter, if I measure the distance from Hanoi to Haiphong, so I should measure this distance by in kilometer, for example. Okay, so distance and size of the body, and distance of anybody. Okay, also the time is very important for us. Is a consists of the succession of event. This event is before the second event, and the second event is after or before other event. Okay, so you see that the time is very important. But in mechanic, you say that the time is independent. It means that it is a linear. It is from the history to the to this time and to the future. Okay, you cannot come back to his history. or for example, yesterday is a before today, and today is a before tomorrow. Okay, it means that it is independent, and it is only in flow chart. Okay, and it plays a very important role in the study of dynamic and mass. With the mass, you can say that which body is heavy or it is very light. You can compare the action of one body to another. Without the mass, you cannot define anything. Okay. uh, uh, you can see that if I want to change the velocity of each rigid body, it depends so much if this body is a heavy or a very large. Okay, and because this mass is a very or is connected with the so-called gravitational force. Okay, and the mass is the property of the rigid body, and with the gravitational constant I can calculate the force. Okay, so-called the weight and gravitational force. And also the force is the interaction or the action interaction of two body, one body to another. The force is characterized by its point or application, magnitude, and direction. Later, you see that this force can be specified by vector. So we call force is a vector quantity. But length, time, mass are scalar. Okay, it means they have only the magnitude, but no direction, and also and point of application, so on. Okay, for example, mass is a scalar. It is measured by kilogram, for example. However, weight or gravitational force is a vector quantity, and the mass of the one rigid body is 5 kilogram. However, the gravitational force is a 50 Newton. Okay, so they are really related. Okay, so much, and that's now is important. Remember well. Here you see I have identified so much, but length and anything is a specified the space. But remember well, I have four quantity: length, type, mass, and force. So I have one first question for you, because it is early morning, so my subjects are very asleep. I say that these three quantity are very important for measuring. It is basic quantity. Do you think that we can define it in any way, or it means that they are independent of each to other? Length, type, mass, force. Do you understand my question? Because I want to specify the relationship between force and motion. It means velocity and acceleration. So I should need length, type, mass, force as a basic quantity for defining it. You have already saw it. They are very basic quantity. Do you think that they are independent or not? I can define any case. Okay, the first question. I have
In
some.
my opinion,
Yes,
that they are, well, in slow motion, they are independent of each other. But
they are
if they
independent.
are,
Okay, let's say. Sometimes you can switch off the microphone. This is good, and throw it. But sometimes if you can send the message via the chat room, okay, because I want to see you, Mr. Who has who sends the answer, Mr. What, Mr. You have already answered the question. This is good. What is your name, please? I want to
uh,
contact with you.
my,
Hiếu?
my name, my name is Hiếu. Yes.
Chat video good. Okay, sometimes you can send, because I see here in on the other computers, so I have, but Mr. Hill. Okay, Hill answer. Okay, Hill. I have some problem with the keyboard on the second computer. Okay, here. But if you send the answer via chat room, it is okay also. Okay, both are good, because if you send the answer on the chat room, I see who is active on the classroom. So Mr. Hiếu sent the answer that they are independent in any way. Okay, it's good answer, but it is not absolutely correct. You will explain it tomorrow. So Mr. Hiếu and other people, okay, I hope that you are not asleep. These are four quantity: length, time, mass, force. They are not independent. Why? Think about it. But I will explain it today yet. Okay, but at least you can see why I cannot define it in any way if you need it. Okay. You see again, I have space in space. I include also the length and something. Time, mass, they are absolute concept. Okay, they are independent of each other. And I have force also. So I have one, four, space or length, time, mass. They are absolute because some minute before I say time is absolute, and force. But why they are not independent of other three? Why? We will see it. Do you think why they are not independent at this moment? Who can have the answer? I will explain it later today. However, if you can give, you can imagine it.
I think it is due to
Oh,
friction.
it's the Mr. What?
Doãn Nhật Minh ạ.
Doãn Nhân Bình. Okay, okay. Do you
Uh,
think
I think force is not independent of the other three because of friction.
of the what?
Of
Friction?
yeah, friction.
No friction. Okay, good. Good that you try to explain it, but no friction. Okay, good. Even if later we see, maybe you, but it is good that you are involved in the question. So you think the friction have no what do you say? No relationship between our question. Okay, later you see why you can define space, time, mass, and force independent. Later, okay. So some other definition. Idealization, you see, like for each other scientific um, fields, the real life is another thing, but you want to try the explain why this mm, this event happened, or why this rigid body has the motion, because I try to find the relationship between motion and force. I want to try to try the answer why the car can move, why the plane or why the bird can fly. Okay, and the real life is very complicated. However, I should make some assumption, some idealization. I can take some model or some idealization. It's very ideal assumption in mechanics. And after defining the model, I can apply to our theory. So you see that idealization simplifying the application of the theory. The more complicated model, it is better. However, it is too complicated to solve the problem. So it depends on the level of complication or level of the difficulty of the model. So you can solve the problem. So you see again one very important task of engineer that you can create the model of the things. Take an example. For example, to take a car. A car, it consists of many small parts. Okay. However, I take two cases. If you want to explain or to calculate only how fast the car move from Hanoi to Haiphong, how long, for example. So in this case, you can take the model of the car by one rigid body, one particle. It moved from Hanoi to Haiphong in 1 hour and a half. Okay. However, if you want to see how comfortable for the passenger inside of the car, So in this case, if you have this very simple model, so you cannot study. In this case, you should take a more complicated model of the car, okay? And you can calculate how the car vibrate, how so car move in the vertical and horizontal direction. In only in this case, with a more complicated model, you can study the comfort of the passenger. Okay, so you see, many the model are very important for us. So in this case, I should have some assumption for idealization. Okay, next definition. You see, I spoke some minutes before about the particle, about the rigid body. What is this? A particle is a simplest model of the things uh, which motion you are studying. Okay, so you see, the particle is a geometrical point without the sign, but they have the mass. So in this case, the particle I can define, but the very small body. They has the mass, 5 kilogram, 10 kilogram, or like a car, I have 1,000 kilogram, but I can neglect the size, or it is no size. Why? Because if I take the model of the particle and I study the motion of the car from Hanoi to Haiphong, so you see that the size of the car 10 meter or 2 meter, it's too small. In comparison, is the distance from Hanoi to Haiphong. So in this case, I can take the car like as a particle. Do you understand? However, if I try to find the comfort of the particle of the passenger, so you see the 2 meter of the car, the length, it cannot be neglected because I will measure the vibration of the whole car. Okay, so the particle I can define it. It is a geometrical point, but has a mass. But because geometrical point, it means that it has no size. Okay, or the size has no influence to the study. And rigid body. A rigid body is a system of many particles, and here in the engineering mechanics, I assume that this rigid body has a compact form. It means that the distance of any particle, they are not changed during the study. Okay, it means that it is absolutely rigid. Later, after this course, you have another say, scientific field like strength of the material or fluid material, and it extended that it means that rigid body is a flexible, is it can deform. But in this first code, in the static and the dynamic also, we assume that the rigid body is absolutely rigid. It means that they have no deformation. Okay, it means that distance of any particle of the body are not is not unchanged. Okay, so particle and rigid body. And now important also Fock system. There are some confusion of the student sometimes. Fock system, what is this? A Fock system is defined as a group of foxes. Oh, anybody can say it. System is consisting of many other foxes. But however, it is very important what I write here in the red color on the body. It means that if I have, or we are speaking about fox system, it means that I suppose that all foxes, the group of foxes, acting on a body. It means a body in English, you understand well. A body means of one body. Okay, it means that if I have a fox system, I suppose or I assume that all foxes acting are one body. Later, if I want to extend our theory to the system of many body, So the Fox system can be extended. However, I should have some other assumption. Okay, but normally if I say Fox system, so I suppose that all forces acting on only one body. Remember well. Okay, I saw that many students and also teacher or other researcher have some some confusion or some error because they forget it that the theory of Fox system are applied. These results are derived from the assumption of acting only on one rigid body, and of course you can extend it, but however the extension should be valid only in some assumption. Okay, because it is a scientific field. All the time you have the assumption, and if you go another further you should have some explanation. Okay, so equilibrium, what is this? Many times today we spoke about equilibrium of rigid body or equilibrium of a Fox system. Again, a body is said to be equilibrium if does not change its position in the chosen space. So it means that it is no motion. Or later you see it, I have the coordinate system with the constant velocity. It means that it is inertial coordinate system. However, I say that it is in equilibrium, no motion. So it is equilibrium. And you see again, this equilibrium is an acting of the Fox system. Again, I have the body under acting of Fox system in equilibrium. So sometimes in textbook they say equilibrium of a body, or sometimes they say equilibrium of a Fox system. Or some minutes before we say a Fox system is a system of forces acting on one body. So it means that I say a, a equilibrium of a body or equilibrium of a Fox system. So they are the same. Okay. So for the forces, I have two kinds of forces also: concentrative force and distributed forces. Concentrative forces, it means that the force have the only magnitude and direction and also the point of application. Okay, at the point of a body. So you can say that it is a concentrative force. Or the area of the point or the application of the load of the forces are very small in comparison of the size of the body. So in this case, I say the concentrative force. However, sometimes I have the distributed forces. It means the force, the effect of the loading um, are acting along the line or along some surface of the body. So in this case, I have a distributed forces or over the volume. So you see, for example, one example, it is for example, if you have the weight, the gravitational force, you see that each particle of the rigid body have gravitational force. However, if I integrate it, I can replace all small gravitational force of each particle, gravitational force of each particle by one concentrated force. It is so-called um, uh, weight, okay, or gravitational force. Okay, so you see it is an example of distributed forces and concentrated forces. Okay, and sometimes in the real life there are some confusion between mass and weight. However, I have already displayed it. Mass is a property of a rigid body, but weight is a force. Okay, with the weight I can define, because it is a force, I can define the interaction of the between two rigid body. Okay, other definition. And now after defining, Mr. Hill should not be good. He said how far. I look at the question. You see explanation why these for quantity are not independent. Good, Mr. Hill. Later I will say I cannot check. I concentrated to my course. So I see you have the correct answer. Okay, good. Who are interacting? So, but good. The good that you are you discuss and think about the course. We enjoy the course. Okay, so that's though it is very important. Also, many error derive are derived of the student or even from engineer. It is from they cannot understand where the basic law is static. I say that like other each scientific field, they are based on some law of the static, a so-called axiom. Okay, axiom. What is axiom of the basic law? It means that the law that everybody feel that it is correct, but they we cannot derive it. You cannot prove it. You can feel it and accept it. If you accept as a law, so you have another scientific field. Okay, in static, you have six axiom or six law. Okay, step by step, step by step. The first law: the Fock system of two Foxes is in equilibrium if they are equal in magnitude, opposite in direction, and collinear. The first thing. What is axiom? Some minutes before, we face so much about equilibrium, about the body, under action of Foxes. But somebody, or maybe for your girlfriend, asking you, you say equilibrium. How you can define equilibrium? Okay, equilibrium we define that they cannot change position. Okay, but how we can prove it cannot change the position? You say that it is equilibrium, but your girlfriend say no, it moves, but in very small motion. What happened? So you see that the first axiom, they say that really this body in the equilibrium if they are under action of two Foxes, they are in opposite direction, collinear, and have the same magnitude. So in this case, surely that this body is in no motion, or in other words, you can say the Fox system should be in equilibrium. Nobody can prove it. So you see here, for example, this particle. Surely, if I have F1 and F2 collinear in one line, in opposite direction and equal in magnitude, surely that this Fox system or this rigid body or this particle in equilibrium. No proof. Okay, we accept it. So why you call it axiom? Okay, do you understand? So the first, it gives us the tool for defining which rigid body. If I see the rigid body under action of these two Foxes, first one, second one, so I say that it equilibrium. Okay, no proof. Second axiom. Here I have only two Foxes. What happens if I have more Foxes? So in this case, the second axiom gives us the tool for it. The action of the Fox system is unchanged. It is the same if I add or remove two Fox in equilibrium. So if I have the car, or I have the house or the building and the construction, the machine and anything with many Foxes, but the motion of this rigid body or the action of this Fox system is unchanged. Step by step, I remove two Foxes, and these two Foxes are in equilibrium. Okay, it will simplify the Fox system. So this second axiom gives us the tool for studying the more complicated uh, case. For example, here I have rigid body with five Foxes. So in this case, F4 and F5 are in equilibrium according to the first law, first axiom. So I can remove it. So in this case, in this rigid body, I have only three Foxes. Okay, so it is only the example for studying to seeing what's the tool we can have, okay, to we have for studying the in engineering mechanics. Okay, I can add, we can start from here. So I can add these two forces, but this body has the same effect, okay, motion or equilibrium. Third axiom, parallelogram law. The resultant force of intersecting forces can be represented by the diagonal of the parallelogram, which has two element forces at the side. You see here, I have F1 and F2, and the effect of this force should be the same if I replace F1, F2 by one force. I so-called FR, FR. Later you see it so-called resulta, okay? Resulta. I can result, R stand for resulta, FR. Okay? It is so-called parallelogram. We have not so much time, but some years ago, many years ago, one engineer very slow or very old, alive in Vietnam. You should call it like a grandfather. They have a big discussion. It started 40 years ago, and later it go also for TV Vietnam, TV in some they Mr. Nguyễn Văn Thường. Okay, maybe you remember this name. Later I will explain to you. The American this law is not correct. It is axiom, and he tried to find another law for this program. Maybe you saw it late, even now in some newspaper, not scientific, but somebody or some journalist can understand where's the problem and take this and discuss it again. I see also the Vietnamese TV. 30 years ago with Mr. Chen Bingbing, give this one to the TV and make a very big discussion in the but it is wrong. Okay, again, if you read some message or some article from this, so please don't be surprised. Again, parallelogram is something like this. F1, F2, I can replace it by the force, which is the diagonal of the parallelogram. Okay, parallelogram law. Fourth one, you know it. It is so-called action and reaction. I have two rigid body, and two rigid body have the action each other. So in this case, this interaction of this action and reaction should be the same, collinear. Sometimes I call action, we write it action is a reaction. However, you see that these two function of A and B and B and A, they should be collinear, equally in opposite in direction. One question for you again. This fox in magenta green, in green color and the red color, they create equilibrium system or not? Do you understand my question? Again, these two foxes create equilibrium fox system or not?
In my opinion, is not.
Mr. What is this?
Nhân, chức năng nhân.
Mr. Nhân, good. They are not. Why?
The force don't act on a body.
Good. Okay. In some textbooks, they say, oh, why? Because some minutes before, we say that if you are speaking about Fox system, with a Fox system, it means that all the foxes should act on one body. Here you see that, for example, fox of A on B, it means that are acting on B. And fox on B of B on A, so it will acting on A. This means that they are acting on two bodies it means that they don't create one Fox system. So if they are not in a Fox system, one Fox system, so there are no sense speaking about equilibrium. Okay, so the answer is correct. But go further. Sometimes you say that in equilibrium. Why? In this case, you should have another axiom. In this case, you should specify it. You can specify, oh, sorry, next one. Next one. Oh, sorry. You need to, okay, because sometimes I can neglect it or not neglect, I can remove it because it in equilibrium. How you can consider it? In this case, only in the action of the sixth, not fourth, fifth, okay, because I have in the sixth axiom. In this case, I make this two rigid body, two particle like one rigid body in equilibrium. So in this case, these two forces are in the one force system, and I can remove it. But how we can consider these two rigid body like one rigid body? It is in one assumption. It is next or sixth axiom. Later you see it. Okay, so it is one axiom. Now you go to the fifth axiom. Axiom. It creates. It is very basic tool for this course for static. It is only this you can do examination problem, and also they say that constraint body, it means that the body with the interaction with the um, other rigid bodies, but I can remove it from the environment from other body and make it like a free. But instead of the constraint of the environment, I will draw the reaction forces. Okay, so you see here, I have one constraint body. I have one force, surely concentrated force, but they are interaction, or they are kept, or they have the interaction with the ground by this support, But now I can remove, I can make this constraint body like a free rigid body. You see here, free body. I remove this support, but instead of this support, I have one reaction force. Instead of this support, I have reaction force. Okay, so instead of this rigid body with environment, I have this rigid body, one force, two force, three force, and four forces, and really I have a force system, and I can start to study this force system. Okay, so this axiom or this basic law give us the tool for calculating of static, and all static course will or we will deal with something like this. Very important for you. Very important for you. You see here, I have one support, the second support, but you see here, this support have only one reaction force, and here I have two reaction force. How I can do it? Oh, why? Later you see it, but very important for you. Very important to remember it. Okay. Next. In the next, in the next hour. Okay. Next time we do it. But it is very important for engineer to see why. Oh, maybe today you studied why this support have only one reaction force like here. Okay, and here for this support I have two components. You can start it to understand. It's quite interesting. Now we go to the sixth axiom. Here you see the flexible body in equilibrium under the action of Fock system will also stay in equilibrium after hardening or rigidening. Although it means that I make this flexible rigid body rigid. Okay, flexible body, I make it rigid. So I say that it is a rigidening or hardening. Okay, So what it means? You see here, normally I have a rigid body, and it is we have equilibrium if I have these two forces. Okay, F1 and F2, and really it is a rigid body under action of force system. It is in equilibrium. However, in real time, I have a flexible rigid body like a spring, for example, some harder. But if this flexible rigid body under action of these two forces and they are in equilibrium, so in this case, I make it rigid. I assume it or I imagine it like a rigid body. So in this case, if this flexible body is in equilibrium, so the rigid body in equilibrium also. Okay, do you understand? This axiom give us for studying the motion of the flexible body. So you see, come back again to this picture. I say why I can consider, sometimes I can consider these two forces like a equilibrium and remove it. So only this case that these two body under action of another things, they are in equilibrium. If these two particles are in equilibrium, so in this case, I can make it rigid. Like or as the case of the sixth axiom, and after making these two particles like one rigid body, I can remove Fa and F2. Okay, do you understand? So you see why we call it axiom or basic law. You cannot prove it, but they give all six. These six axiom give us the tool for studying the static. Okay, so unit of measurement: length, time, mass, and force. These are four. Really, Mr. Hill, later you see that even I have these four. One, two, three, four. On the first one, second one, third one. But they are not independent. Why? Later, in the dynamic course, you have the axiom. But here, today we are speaking about static axiom. However, I have a dynamical axiom, and the three first dynamic axiom, it is so-called three Newton law. The one, two, second Newton law is F equal ma. So you see here, F is the force, m is the mass, a is acceleration. You can define it by length and time because it is a meter per second square. Okay, so you see this is one like a static axiom. It is a dynamic axiom. We cannot prove it. We can only see or you can feel that it is correct. So really that, so if I define m, I define length and time in some way. So in this case, unit for force should be or should be include or according to this consistent according to this law. Okay, so you see that all these four quantity are not independent and they are coupled by this second Newton law, okay, or second dynamic axiom law. So over the words, you have two system of units. The first one is so-called SI or SE. In Vietnamese, it's like SE. SE. In English, they call sometimes because we are speaking English, so it's like SI, but really it is normally we should say SE. Why? Because it is from French. Système de unité internationale. Okay, Système de unité internationale. So S stands for system in French, and I here stand for E in French. International. Okay, so in translation into English, it is an international system of unit. Okay, and For international system unit SI, you have three basic system unit: length by meter, height by second, and mass by kilogram. So surely in this case, according to the law F equal, so you see the unit for force should be 1 Newton. Is a Newton is the force which, if acting on the mass with 1 kilogram, will give the particle with 1 kilogram 1 acceleration, 1 meter per second square. So you see 1 Newton is okay. So you see, really I cannot define the unit of forces in any way independent, but should follow this law. Okay. In the second, over the world, it is a so-called US customary units, or sometimes I call it FPS. FPS, big one. Why? FPS, F stands for the foot. It is the unit of the length. P stands for power. It is the unit for the force. And S stands for second. It is a unit for time. So you see, in US customary unit, or FPS, okay. And in this case, mass is a derived unit. Mass M is F divided by A. Really, it is from the second Newton law again. And in this case, I take slug. Slug is a mass of one particle, which is under action of the force 1 pound, okay, pound, and will have the acceleration of 1 feet per second square. Okay, second square. Okay, here it is square. Okay, it is some arrow here. Okay. So another thing, this thing you can read it at home, and it's quite easy. Sometimes you see you have a dimensional homogeneity. It is a way for the student to check the correct answer in your problem. Also, in the equation, the dimension of the equation or the result should be the same on both sides. Okay, on the both sides, on the left side, on the right side. It means that if you have some equation, so you should have the dimension of the the unit on the left side and the right side should be the same. Okay, and these are two things: significant figure and rounding off number. It is very important for you. Oh, surely it connecting with the calculation. I don't know what happened with you some month ago. You see that due to the pandemic COVID-19, last semester all our university should we have already wait, but the situation is too bad that you should make a examination in offline online way. And one of the big problem is rounding off number and significant figure, because if you have the quizzes, okay, the result and the machine calculator make a mark for you, and it is very important if you have good result or not, and the machine cannot recognize the correct result or the bad result if you don't have enough significant figure, and reading the calculation you have the big rounding off number. So pay attention. Normally, for example, if in the mechanic quizzes, okay, or examination in online way, you require you to calculate with the four significant figure. Only in this case, the result can be compared. The machine can compare the side. Okay, the answer is in one. Normally in engineering program, they make three or four significant figure. If if uh, if in the correct in the final result, if I require three significant figure, so in the intermediate calculation, you should take a four significant figure. Okay, significant figure is any digit including zero, but specifying the location of the decimal point of for the number. If you cannot remember, understand where, so please read this thing and the textbook and try to understand. Maybe it is very important for you at the end of the semester if you are continuing with the online examination. Okay, and you see here, pay attention to rounding up, okay, and significant figure. Read this thing at home. Okay, now we go at the of this chapter at the conclusion. In static, you have two problems. We are speaking so much about the condition of equilibrium. We will do together is a theory, is a theoretical part. Try to find why this system is in equilibrium. Write the equation of equilibrium. And with the equation of equilibrium, we will write the reaction forces. Okay, for each for each for each force system, beside of a given forces, I have reaction forces. Okay, come back again to this picture. For example, here it is one typical problem in okay, it is too slow. I wait. If you here this picture, you see that I have one rigid body. I have one rigid body under action of the so-called given force. This force, okay, too slow. I'm waiting. If you're in your screen, but I have two support. This one, first one, and the second one. And the task of the engineer is to try to find the reaction forces is the support here. So in this case, I should remove, and you like an engineer in the examination and in the homework, and later in the future, your problem is to specify how large these reaction forces. So you see that the first thing you should be able, should be capable to remove this support and draw these forces. Okay, draw these forces in red color, and after that writing the equation of equilibrium and calculating. Okay, this picture. Okay, so you see that the like a theory you will do together with you with me finding the condition for equilibrium. Sometimes in the examination this file also, but normally uh, the question for you is static course is specified the reaction forces in equilibrium. Okay, so now we go to the second chapter, but it is better now to have a um, break. Okay, one break, 10 minutes or 10 minutes. Okay, 10-minute break. Then after that you can we will continue. It's a second chapter. Okay, 10-minute break. Okay. nhờ cái này đi vòng đây kìa. Nhớ cái này là ngày xưa nó phải bấm cái ấy như nào nhỉ? Sorry. So we can go. Do you hear me well? Okay, let's continue. We have some problem with the keyboard, so okay. Fox system. Do you hear me well? Okay.
Yes, sir.
Okay, good. So you see,
Yes, sir.
again, we have Fox system. We have already discussed that in static, we are dealing with the Fox system. It means that a Fox system, they are acting on one rigid body, and in equilibrium. Okay, so what is a Fox system? Later, you see Fox system, you can apply it for rigid body which move also. But at this moment, we'll define what is the concern with the Fox system. Okay, and later you see Fox system in equilibrium or not. Only if Fox system or rigid body will move or it will be at rest. So in this case, you define many things. Okay, for example, you define the vector of the forces, and with the vector of forces, because you see that force can be defined as a vector, and with the vector definition, you can use many mathematical tool. Okay, and with this, you can explain the Fox system in 2 or 3. Oh, sorry, it is better to. Okay, it's better. So you see that you can specify it. It's a 2 or 3 dimension. And beside of Fox, one important thing in chapter that you will define also the moment of a Fox. One very important thing of the Fox system is beside of Foxes, but you should be able to define the moment of a Fox above a point or above a specific axis. Okay, it is important not only for this course, but later in your engineering future. This moment is very important, not above axis, but above a specific axis also. And also, and after that, preparing for the specifying the case where the rigid body is in motion or in the rest, you should be specifying the result of non-concurrent forces. Today, you will be able to specify resultant force, but for concurrent forces. Okay, and later, for very complicated and very general cases, even non-concurrent forces, you should specify resultant. Okay, so some important thing for you, you can see here. You should specify force vector, the force like a vector. You should specify resultant force, but today you will specify only resultant force of concurrent forces, which means that the forces which intersects. Okay, and will be able in the end of the chapter specify the moment of a force above a point or an axis, and specify resultant. And with the resultant force, result couple, you will be able to reduce a force system from the very complicated force system. Okay, Mr. Tung, can you upload slide and textbook later? So maybe you go to to join the course later, I say that this week on step by step. Okay, I will upload the slide and textbook on the team. Okay, I don't give it at the beginning of this course today. This morning, early morning, I show all the textbook and reference book also. This is so much. However, I will upload each chapter with the problem and also the slide. Okay, on the team. Enjoy the team and see it. Okay, Mr. Tung. I'm sorry because now I check on the chat room and see later. And concentrate to the very important for engineer to see where are you and what we are doing. Okay, you see again in this chapter we define a fox and later we define resultant fox and coupler, and with these two things, resultant fox, resultant coupler, you should be able to reduce from the very complicated fox system to very simple, to simpler Fox system. Only with the reduces simpler Fox system, you can see if this system or this rigid body move or in equilibrium. Okay, so it is why we have the one chapter for Fox system. Okay, first thing, Fox vector, maybe it is nothing new for you. Normally, not only in mechanics, in any scientific field, you see you have two kinds of quantity. Like today, you see mass, volume, length, and force, and acceleration, velocity, and also, okay, you have two kinds of the curve. The first one is scalar. The second one is vector. A scalar, it is a quantity. It characterized by only one number. Okay, it is this number can be positive or negative. You see that if I have mass, I have volume, I have space, I have distance, length, time, for example, it is a scalar. But the vector, instead of the scalar, it has not only magnitude, but I have the direction. So if static is a vector, very important, for example, position vector. I specify because I have coordinate system, so each point can be specified by distance from the origin of coordinate system to the point, but I can connect it by one vector. And Fox vector also. Coupler of the moment is a vector also. Velocity also. Okay. The vector quantity should specify by magnitude, but also point of application and also the direction. Normally, in the work in higher region, a vector is generally represented by a letter with an arrow over it. Okay, here, for example, vector A. We discuss or later, especially in the time of revolution 4.0, with the computer things. So normally, in this case, this notation is very important. That you can use so-called matrix form, algebraic form of the vector. You will try to draw the vector by one letter in the both face. Okay, in some slide before you can see, for example, when I write F equal MA, if you recognize, some clever student have already recognized that I write F. It is boldface F. A is a boldface A, but only M is in italic one. In this case, it means that F and A are vector. You see here, I symbolize it by boldface letter, and scalar is specified by italic way. Okay, you come back again. So normally, in a row, we call it geometrical presentation, and here is so-called algebraic presentation or matrix presentation of vector. Okay, so notation you can see here. Geometrical vector. I write A with the arrowhead, and algebraic vector, or sometimes we call it in computer with connecting with computer, we call it algebraic or matrix vector. Okay, right here A. And in this case, A has a three component, AX, AY, AZ. Normally, I like A like a column vector, okay? But better for using like in textbook, I write it in one row. So I transform it from the column AX, and below it is AY, and below it AZ. But it is it requires a lot of space, so it is better to write in one row. So in this case, I write AX, AY, and AZ, three components in one row, but with the transpose. T stand for transpose. Transpose operation. Okay, so you see again, if I have geometrical presentation, algebraic or matrix representation. Okay, and if I have basic in coordinate system in geometry, I have three unit vector I, J, and K. Surely, if I have algebraic or matrix form of representation, I can write I, J, and K both ways. But here I have geometrical vector, and general or arbitrary vector can be write by combination of these three unit vector IX, IY. Oh, sorry. Oh, okay, too slow. I scared if of an error with the machine or something like this. AX, AY, and Z. So you see, if I write here, I use algebraic vector, so I have three components. Here I have three components also, so you see that really in the matrix form I can write very easily A, right, AX and Y, AZ. For geometrical form I should write something like this, AX, AY, AZ. Okay. And again, I emphasize that in this course, scalar quantity will be symbolized or will be represented by italic letter, like here, AX, AY, and AZ. They are italic quantity here, AX, AY, AZ. Okay. So, and now for Fox vector, how you can define it in 2D problems? Too slow. I am waiting. Oh, yeah. So you see that if F is a Fox vector, so you see both the face, and I and J are unit vector I and J here. So Fox vector F or any other vector also can be represented by two components, Fx and Fy. Okay, here you see that if I write here, it should be scalar. However, like a parallelogram, if F is represented by two foxes, Fx and Fy, so you see again, you can be like a vector also. So okay, so if F is represented in 2D like here, so I can calculate the magnitude very easily by using Pythagorean theorem. Okay, by Pythagorean theorem, I can calculate the magnitude of the force very easily, Fx plus Fy. And the direction, because I know component, I know magnitude, so I can calculate the angle of Fx or Fy very easily from the trigonometry, okay, by cosine. By cosine, normally in the English textbook, they write in Vietnamese, normally they say, for example, in Vietnamese textbook, they say arcus cosine, okay, but in English textbook, they write cosine minus or tangent minus with Fx and Fy. Okay, Here it is magnitude and direction of two components, alpha and in the similar vice versa. In similar way, I can calculate the angle beta also. But surely alpha and beta are not independent. We can calculate it by cosine square alpha plus cosine beta square equal 1. Okay, and one important thing in many things, because you write the Cartesian coordinate system, you can specify the unit vector also. Very important. Unit vector here, if I have the two components fx and fy, I can calculate the unit vector of force F along this line of application. Very important for us. Pay attention to this. It means that if I have a magnitude F of force F, I have a magnitude. So I should specify direction vector, direction unit vector with the magnitude and direction unit vector. The vector is specified completely. Okay, so you see here again, I have two components, fx, fy, magnitude, and or you can write very easily using cosine alpha and cosine beta. And the vector f is specified completely with the magnitude f and unit vector. Today we have some example to do. You see that why unit vector is important. Unit vector show us the direction of some line, and here because I have unit vector, it means that I know the line of application or direction or line of application of force F. Oh, you see here. If I have force F and I want to project this force to some line with the unit vector AA. Again, I say that a vector 8 with the unit vector 8, it means that I can specify a line very easily. And now, how we can do it? You can show it in some minutes, but somebody can give how we can do it. If I want to project force F to the line AA with the unit vector A, who can give some suggestion? Okay, I give you 1-2 minutes. How I can do it? Project force F. Say I have this force F, and now I have some line. I have some line here on the space or on the system XY with the unit vector A. How I can do it? How? I have the how? I have some problem with the keyboard of my second computer. Okay, so good. F online FA. Okay, Mr. Bình, good. But in this case, you should say dot product because I have two vector. Okay, vector F, and vector A, unit vector A. In this case, I should provide dot product. Okay, I say dot product. Dot product. It is very important. Dot product. Okay. Here you see I have two unit vector. So you see dot product of F. Here it is a projection of F on the line A, on line A with the unit vector A. So I provide dot product F times A. So in this case, from mathematics operation, you see I high F plus Fi high AI. So you see again why with a convenience, you can use a matrix, vector form of the foxes to specify. You can do many things. Do you understand? Okay. And wise so-called rectangular component of the fox F. It is quite easy for you, but important. Now I make or we have already made the example y with the convenience of the projection F on the line AA with unit vector A. You see that with the vector presentation, you have a lot of mathematical advantage for doing in not only here but also for mechanics and so on. Addition, subtraction, also here it is only projection. The same you can do for 3D problem. In 3D problem, I have a coordinate system which y and z, x, y, and z. Again, so in this case, x, y, and z can be represented by 3 unit vector y, j, and k, and 3 component fx, fy, and ffz. Again, if I have a matrix representation or algebraic, so I have 3 components fx, fy, and fz, like transform row vector. Okay. And again, magnitude can be calculated very easily by using Pythagorean theorem. Okay, fx, fy, and fz from fx, fy, and fz. With the direction, so I calculate again alpha, beta, and gamma by using the component and also the total magnitude. Okay, surely alpha, beta, gamma are coupled by this relation cosine square alpha plus cosine beta square, surely cosine gamma equal 1. Okay. And again, if I want to specify direction of fox F, it is sometimes I can calculate it. I can use so-called direction unit vector using these triangular alpha, beta, gamma, or using the form of unit vector like here. But here surely 3 component of this is cosine alpha, cosine beta, cosine gamma. Again, if I want to project fox F with on the line, project it on line with the unit vector 8, I use again dot product F times 8 again. But in this case, 8 have 3 components, F 3 component, so it is very easily that I can after finding, it's too slow, the network Wi-Fi is also very slow. I wait. I'm waiting in your screen. Okay. Okay. So if I provide dot product, so I get fx, fy, and fz very easily. So it is a presenting vector, not only for fox vector f, but any vector can be found very easily by using this. Okay. One important thing for the student: right-handed coordinate system and right-handed rule. Many students forget it, but especially in mechanics on 3D mechanics, it is very important to use this law, so-called right-handed coordinate system or right-handed law. What is say? If I use my right hand, so I see that I have 3 components: x, y, and z, x, y, z, x, y, z, x, y, z, or 1, 2, 3, 1, 2, 3, 1, 2, 3. But how we can do it? I say that if my finger show the positive my finger, okay, shows the positive vector of the first axis to the positive direction of the second axis or second axis. So the thumb will show the positive vector, positive direction of the Z, or the third one. Okay, X, Y, Z, or 1, 2, 3. Again, I repeat it. If my finger showing the curling from the positive direction of the first axis, curling, okay, of my finger from the positive direction of the first axis to the positive direction of the second axis, and the thumb will show the positive direction of the third axis. Okay, in this case I have X, Y, and Z. So I have a set 1, 2, 3, but now I can say it in the X, Y, and Z. If my finger show the curling from the positive direction of the X-axis to the positive direction of the Y-axis, so the thumb will show the positive direction of the Z-axis, but X, Y, and Z, but I can say 1, 2, 3. So the same, because I say 1, 2, 3, 1, 2, 3, so we can show if my finger, my curling, my finger will show the curling of the first axis. In this case, I can take the first axis Y, the Y-axis, to the second positive direction. In this case, the Z, to the Z-axis. So the thumb will show the positive direction of X. 1, 2, 3, 1, 2, 3, 1, 2, 3. You can show it X, Y, Z, X, Y, Z in any way. Okay, so repeat it many times. I will repeat it. It is very useful for you. Okay, and if I apply it to the two-dimension problem, so in this case, Z-axis for two-dimension problem is directed outward. It is to me, to us, perpendicular to the base. So in this case, you see that I can use the curling vector. It is counterclockwise. Okay, counterclockwise. So in this case, the thumb will show to us, to me. So in this case, outward. Okay, and it is positive. And if I take a clockwise direction for 2D problem, so you see that the positive direction is it is negative. Okay, it means that it inward to the page. So remember, well, I think it is a very useful rule for the students, so I repeat it before going further. Now today we will have the first example. Next time we have more example and some quizzes also, very fast. But today, because we have some problem with keywords, the first we look together. I have one foxes. You see here. You should imagine it is a geometrical. Okay, and I have one fox here. I have one fox here, and it is a fox. I have all three. Okay, and try to find the projection of this fox F with the magnitude 300 Newton with the direction shown in the picture, and projected into direction of OA. Maybe it is for you. It is more complicated to understand well the direction, but try to find. Okay, I give you some minute to make orientation in this this example. Try to find. So plan is something like this. Because I want to find I want to find the projection into OI, so I should specify the position vector ROA. And after finding ROA, I find the unit vector UOA. And later, you find the angle F. Or you can find directly projection by using dot product F type UOA. Or you can find the angle theta also. You can, the step 2 or step 3, you can mix it. Okay? It important that you find unit vector UOA and provide a dot product of the Fox F to unit vector UOA. Okay. Mr. Viết Hữu Trường Giang, good. Okay, so we will see if you are writing you correct or not. Okay, good. You are waiting for other students. Okay, so okay, so we can go. So quite easy because from the geometry you can find from the parameter or the given parameter here, you can write very easily the distance here in the direction I, J, and K. Okay, unit vector. And from this, I can calculate the vector ROA. And with these three things, maybe it is a bit more complicated for you with the geometry, but it is not a problem of mechanics. It is problem of geometry. So if you cannot follow it, so later at home, read very carefully. So important is that first thing, we calculate the position vector, okay? And I calculate the magnitude. With the magnitude, so you can calculate the unit vector. It is important. And now if you can write the F directly, you can provide a dot product. However, it is better to give some immediately, I project it F in this direction of this plate. Okay. So you see, with this direction, I can have these three component of F. Three component of F. And with this one, you can provide a dot product with unit vector OA and Fox vector F, okay, and get the result. However, following the step, I have already, sorry, I show some minutes before, you can calculate the angle beta, but here it is dot product. And angle theta also. Okay. Here it is a dot product, and because here it is ROA, I should specify the magnitude of projected component F along the OA will be, okay, F with the unit vector. So Mr. Nguyễn Trường Giang, it is good. Okay. But if you have FOA, you can provide it directly. However, component, it is Mr. Trần Minh Hiếu. The component of F, it depends. It is not so complicated. Okay, it depends. It is a problem of geometry only. All the time in the given problem, you should imagine if the forces are acting in which way. Okay, it is a for example, angle theta. If it has the in this for example, in this plane, and after that you have some angle from the from other axis. Here force F are acting in this plane. Okay, so we write it F apostrophe, but this apostrophe, this plane have some incline according to X and Y. Okay, it is only the problem of geometry. Not okay. Next time for other problem, it is another. So look at home and specify it or imagine it by yourself. Okay, it is not so. It is not a problem of the mechanics. This is only the problem of geometry. Okay, it is complicated even for me sometimes. Okay, for engineer, because you should imagine how the force acting it. Normally in examination, you will specify it very in detail for student, not my confusion. Okay, but because here I take some example from other source to make only the step. If you don't imagine it, so take it easy. Okay, Mr. Hill. Okay, go further. Important that I can, after finding the unit vector, I can provide a unit dot product for finding the projection of force F for into direction. Okay. Okay, you see again. If I have F, I have cosine. There are many ways to give. There are many ways to give to get the result. So the first example, we can go further. And now we have already said at the beginning of this chapter, for finding the or for studying the force system, two things are very important for you: that resultant force and resultant coupler. And today we start with the resultant force. But resultant force at this moment, you will study only resultant force of concurrent forces. It means the forces which intersect, or you have the one common point. For example, here I have F1, F2, F3, and we call it concurrent forces. Okay, concurrent forces, that are the set of forces which all pass to the same point, not only in 2D but in 3D problem. And in this case, I can say a set of concurrent foxes applied to a particle may be replaced by a single resultant fox, which is vector sum of the applied foxes. Okay, you can prove it in many way. You can many way. How you can see here, that if I fix some point and I draw the parallel line, I bring F1 from the original position to from original position to slow. Okay, from original position to this position. Okay, and at the end the same I do for F2. As the same I do for F2 at the end of F1 here. I bring F2. I draw parallel line and I bring F2 here. Okay, I have F2 here. The same at the end of this, I bring it F3. Okay, the same for F3. And the connecting is FR. R again stand for resultant force. You can prove it. Or the second way to prove it, it is quite easy, that you can apply the parallelogram. For example, F1, F2 can be replaced by one diagonal. And with the new diagonal, I can draw parallelogram for diagonal with the F3. And in this case, really step by step, you see that really the system of these three foxes can be replaced by only one fox. Okay, but it is only explanation. So you can see here, F1 and F2. Here it is another example. But however, you see here, first thing, I draw F1 and F2 by 1F with F by parallelogram. So you see that vector fox component 2 or more foxes have the same effect as a single foxes. By using parallelogram, parallelogram is the third static axiom, the third basic law. So it means that step by step, for example, these are three foxes, or I replace F1 and F2 by one fox. When this one fox is the new fox, I apply parallelogram. So at the end, I have only one fox. So you see that by using third axiom, third static basic law, you can see that two or three or fox vector can be together to give together the same effect as a single fox. Okay. So, but vice versa, you see that one fox can be resolved into two or more foxes. Okay, but I have a many way by parallelogram, but here you see that I have many way to do it. Here, for example, one fox F. I can explore it by using parallelogram with F1 and F2, like in this picture. However, in another way, I can explore it in the second picture. In the second picture, I have another F1 and F2. So you see, by resolving, I have a many fox component. Normally, if I have F, I resolve it in three perpendicular orthogonal. It means that Cartesian coordinate system is better. Okay, so come back again to the topic of this portion. Resultant fox of several concurrent foxes. Okay, concurrent foxes. How we can do it? How we can find a result of several concurrent foxes? Okay, if I have a fox system which include F1, F2, F3, and many foxes. Okay, waiting. Okay, so I have a fox system, many foxes, F1, F2, and Fn, and each fox Fk, run from 1, 2, 3 to n, have three components. I project it into Cartesian coordinate system. I have Fkx, Fky, Fkz. So I have the fox system with n foxes. And no resultant foxes because I have is can be replaced by only one resultant force by adding algebraic. If I have the vector, so Fr can be calculated by F1 to F2, F3, and Fn. So I have two ways to do it. The first one, I have drawing method. Drawing method, it means that I drawing polygon of forces by applying the parallelogram. But it is like here, step by step. Okay, using. And it is so this picture is so-called parallelogram. The proof of this we have already mentioned some minutes before. This is so-called drawing method, but it is too complicated for us. Okay, not too complicated. It's hard work. Okay, it is better to use projection using that the H fox can be represented by component in three component. Okay, so you see H fox can be projected into X axis, Y axis, and Z axis. So I can write it using unit vector I, J, and K. So these are three FRH, FRY, FRZ is the summation of all component in X, Y, and Z. Okay, all component X, Y, and Z. Because these are three component, we can calculate the magnitude again by using Pythagorean theorem. Okay, and also with the magnitude, I can calculate also the unit direction of unit vector. Okay, direction of unit vector again by alpha, beta, and gamma. Okay, sorry, alpha, beta, and gamma. And now I gave you the one algorithm. It is quite easy, but maybe it is useful for you to calculate it. Okay, if I have two vector, if I draw parallelogram, I provide a sketch with the two sketch. I or using the editing, I sketch this parallelogram for these two foxes, and label it exactly with the letter what I know. And after that, using trigonometry, I can calculate the diagonal of this parallelogram to calculate it very easily. Okay, the trigonometry I use the especially two law, sine law and cosine law. Sine law with the sine, and cosine law with the with the cosine for calculating the magnitude of the diagonal. Okay, these are two trigonometry law are useful for you to calculating the addition of two foxes by using either parallelogram or either algebraic addition. Okay, last example today. Very easy, but maybe it is the first quiz or first examination. I hope that the COVID situation will be better. I have three concurrent forces, I think. So try to find magnitude and angle of the resultant forces. I have the here we have only two-dimension problem. Okay, I have X, Y, and Z. It's quite easy. I give you 2 or 3 minutes. We do together. Okay, make orientation. Okay, Trần Văn Minh Hiếu, good. You will see if you are right or not. Okay, wait a bit. Okay, here is a hint for you. Quite easy. Okay, each foxes, the different are not the same. Okay, you will see. Okay, for each foxes, I resolve it into x, y, and composite and provide a summation in the direction and find magnitude and angle. So you see, first one, fx. Okay, it is in y direction, so quite easy. Fy, f second, f2, and f3. Repeat it. Okay, quite easy. So you see then. And after the example, this step, I can provide a summation each each component. Okay, so after providing this, so I can get very easily the magnitude and direction. So Mr. Hyo, it is very fast, very quick, but fast and furious. Okay, the quick, pay attention. So in this case, if I have quizzes online, okay, and the machine will make a mark for you, so it is not so bad. It require only the number. Mr. Tung and Mr. Bing is better. Okay, good. And now it is the last slide for you. And today, please take an example. And tomorrow I will post, because today I don't have some problem with the computer. I will send the textbook. So read the text and example in section 2.2. Okay, and so you will start the solve the problem in small textbook. Today you can do something. Okay, and somebody know me from the other course. You know that you can send the solve the problem to me. Okay, and I will make it and register your activity, and this one all the time your participation on the your activation you are active or not in the course, and also the homework will be in the midterm score. Okay, midterm score. And when you send the problem, please send only one file. If you have more problem, please compress it and send me only one file. And in the name of the problem file, write your name and the number of the problem. Next time I repeat it, but today it is enough for you to study. Okay, it is okay. I hope that you enjoy the lecture today. It is the first time you have many problem with the computer and also with the Wi-Fi, but I hope that next time we see. But today is not completely okay. I will check it because there's no team will check instead of me, so I don't do roll call. Okay, so but I will see who joins the course inside and outside and left and also. So remember well, read the text and example, solve the problem, discuss with your problem, and send the with your friend and send the problem to me. Everything is okay? Something more? Question? What is a numpy? What did I hear numpy? What is this? What is a numpy? I don't know. Mr. Hoàng Đình Lương An or something. Okay. If you have any question, it's not okay, mistake. So bye bye. If you not
Teacher.
okay.
Can you upload all the slide for static?
What? What do you want? What do you mean? I cannot I cannot catch your question.
Yeah, he
I think
asked if you can upload the slide of this.
Oh,
lecture.
sorry. Okay, I said
Yeah.
already at the beginning of this course, Mr. Hoàng Đình Lương An. Maybe I check it. Maybe you join later to the course. I say that tomorrow I post the slide and also some topic of some portion of the textbook on the team. Okay. Okay. So if you have no question, so see you again. Okay. Bye bye. See you soon.